Okay, so this is a Hubble Space Telescope, which is, again, the first major optical telescope launched like 30 years ago. Above the distortion of the atmosphere, far, far away, above rain clouds and light pollution, this Hubble has unobstructed view of the universe. And scientists have used this Hubble Space Telescope to observe the distant stars and galaxies and planets in our solar system, such as Saturn. And you can also see these moons of the Saturn and the supernova explosion. And this is the gas expelled from red giant star. Some remnants of the stellar blast again, different types of galaxy. That's called NGC 5643. That's 60 million light years away from us. Now here's a question. What's the diameter of these galaxies in light years? Several hundred light years? Oh, no. It is 100,000 light years. So the diameter here, that means you have from here to here, 100,000 light years. Light starting from here goes to the other end. It takes 100,000 years. It's truly crazy big. Now, next question is, how many stars, estimated, right? Estimated number of stars. How many stars do we have in our galaxy? How many stars? The closest star from our solar system is Alpha Centauri. It is about 4.3 light years away. So based on that, and also based on the relative darkness and brightness, scientists can estimate it. Of course, you cannot really count them individually. You just estimate. But so numbers can be off, but it's not going to be far off. You can still estimate some. So we have 200 billion suns, in a way, in our own galaxy. It's crazy, isn't it? It's really crazy. And then these galaxies, we talked about this one galaxy that's 100,000 light years in diameter, and it contains around 200 billion stars in one galaxy. And now these galaxies are actually clustering. This is called a galaxy cluster. So the universe is really big. And so estimated number of galaxies in our universe, of course, this number can be also off. I mean, every time new research comes out, the numbers are different. But just rough numbers. And the estimated number of galaxies in our universe is around 2 trillion. So we have 2 trillion galaxies in our universe. I mean, latest research says, oh, no, that's too much. That it's going to be 200 billion. But anyway, it's a huge number, whatever number that is, right? Okay. So we know that the universe is humongous. Now, the questions are, how was our universe created? How did it come to be the seemingly infinite place we know of today? And what will become of it ages from now? So these are the questions that have been puzzling philosophers and scholars, as well as people like us. Now, today, the consensus among scientists, astronomers, and cosmologists is that the universe was created in a massive explosion that created the majority of matter. This is known as the Big Bang theory. The Big Bang hypothesis states that all of the current and past matter in the universe came into existence at the same time, roughly 13.8 whatever billion years ago. At this time, all matter was compacted into a small ball with infinite density, infinite heat, called the singularity. Suddenly, the singularity began expanding and the universe began. Well, this is not the only modern theory of how universe came into being, and there are several others. Still, this Big Bang hypothesis is most widely accepted and popular. And then this Big Bang model has two theoretical foundations. One is general theory of relativity, and the other is the cosmological principle. So in this lecture, we're going to focus on this cosmological principle because this is extremely important. It is extremely important that we understand what that is and what is behind that principle, okay? So first, just quickly, general relativity provides a unified description of gravity as a geometric property of space-time. So basically, the curvature of the space-time means that the light path will follow the curvature of the space-time here. So since the space-time itself curves, so light goes straight within the space-time. However, because the space-time itself curves, the light appears to be deflected. So that is what happened. And also this is not just a theory, but also experimentally verified several times through different methods over the past 100 years. Here, the thing is the curvature of the space-time implies that there is another dimension, or the fourth dimension. Since you see this graph, and this is like 2D. So what happens here is we are living in this 3D world, and assume that we are living in this XYZ world, and assume that we compress this Z-axis. So we convert our 3D space into 2D space. It becomes like a paper, 2D, right? X and Y only. So that is what you are seeing here. Now imagine that this space now, like a paper, right, is curved. When we say the space is curved, that means our universe in two-dimensional representation is curved. Okay, so that's how you understand. So the thing is, in order for this to curve, right, and there has to be an extra dimension where this two-dimensional space-time can be curved to. Okay, so that is a fourth dimension. Another pillar that supports the Big Bang theory is the cosmological principle. The cosmological principle is the notion that the spatial distribution of matter in the universe is homogeneous and anisotropic when viewed on a large scale. Here, notion is a conception of or belief about something. So basically, cosmological principle is the belief, is a conception, okay? It is not the scientific rendering. It is kind of philosophical thing. It's important that you understand that later, but I'm gonna address this later, okay, in this lecture. So, but this is just what you find as a description in the textbooks, okay? Now, so cosmological principle says the spatial distribution of matter in the universe is homogeneous and isotropic when viewed on like 100 parsec scale. So here, a parsec is equal to 3.26 light years. Therefore, 100 megaparsec would be 326 million light years. So in other words, it says that the spatial distribution of matters in the universe is homogeneous and isotropic when it is viewed on a scale of 326 million light years. How about the age of the universe? Here I present you a simple way of estimating it. It is not an accurate way, but it's good enough. And also this is on the website of Penn State astronomy department. So it's not, okay, kind of standard estimating it. So the distance here between two galaxies is denoted d, large d, okay? And the apparent velocity with which they are separated from each other, the galaxies are separated from each other, is v. V is the velocity, or the galaxy separation distance, the velocity. The time it takes to reach their current separation is t. T equals d over v. All right. Now you don't need to know everything here, but just follow the flow. Okay, just follow the flow. You can take 1 over h naught, which h naught is a Hubble constant, which is measurable, and 1 over h naught is going to be your estimated age. So basically, you see this last line on the bottom, t equals 1 over h naught. So basically, you know the Hubble constant, you can estimate the age of the universe. So in seconds, it is a 10 to the 17, 4.22 times 10 to the 17 second, and put it into years, it becomes 13.4 billion years. And of course, this is a rough calculation. A more accurate calculation is a bit more complex, as we need to consider dark energy, dark matter, and then we have to put the integral or these things. But the number is not that different. It's 13.8, 13.7, and so actually it's very similar, right? But simply put, at the end of the day, the age of the universe is just an inverse of Hubble constant. Of course, this is because we assume that the universe began from a singularity with a constant expansion rate on the most part. So when you say universe age is 13.8 billion, it's just a simple calculation, okay? And again, this Hubble constant itself has been measured using several different ways until very recently. Here, you see the graph on the bottom right, you see this 2020. So it was measured until like last year, a few months ago even, okay? And see this range of the numbers. You can have different numbers here, and you put different numbers, then your age becomes different also. But it is clear, but nevertheless, you can't really deny the fact that the universe look very old. You cannot deny that the fact. Okay. The problem is then that is different from what the Bible says. Okay, so that's what we are addressing today and next time, especially. So, how do you reconcile this? The problem is, again, the Big Bang hypothesis is not consistent with what the Bible says. The Bible says, especially in Genesis 2:2, and by the seventh day, God had finished the work he had been doing. In Exodus 20:11, he says, for in 6 days, the Lord made the heavens and the earth, the sea, and all that is in them. Exodus 31:17, for in 6 days, the Lord made the heavens and the earth. So Genesis 1 describes the 6-day creation plainly. So how do we reconcile these two different numbers? Or do we have to just completely ignore the Big Bang theory and the age it claims because it is not consistent with the Bible? Although it really appears that the universe is old. Well, unfortunately, when it comes to cosmology, things are not that simple. The universe is really big. The observable universe is a sphere with a radius about 46 billion light years. So say our galaxy is at the center. It is in our point of view, right? We are at the center. We just look around, and the light starts from us. It reaches the end. It takes 46 billion light years. Now, there's a problem here. A light year is a measure of the distance that light can travel in 1 year, right? So how is light from distant galaxies, in some cases coming from 13 billion plus light years away, arrived on Earth in a matter of days, according to Genesis 1:14-15, where it says that the light emitted from all the galaxies billions of light years away arrived on Earth on the 4th day of creation. So this is called light travel time problem, which is the challenge of how starlight from millions of light years, billions of light years is visible on Earth in the present day if the Earth is not millions of years old. Okay, so maybe we should not interpret Genesis narrative literally because it doesn't make sense. It is not scientifically sounding. No, what do you think? Maybe I want to hear your opinion here. What do you think? Anyone? You can unmute and maybe share your thought here. So it is looking very clear. It is almost evident that universe looks really old. As long as we assume that universe starts from singularity and the light speed has been constant right throughout, then there's no other way to interpret. Then do we have to just discard Bible? Anyone want to share your thought? Maybe one person.
I can share.
Sure.
So there's a lot of assumptions that go into the creation of the universe based off the fact that there's a singular point of creation and the fact that all the matter travels at a constant speed throughout all of history. That's a scientific assumption.
So Bible says a literal day, okay, and science says otherwise. What do we do here? How do we reconcile these two stark different stuffs, right? So that is something that I want to address, and actually that is being studied and researched in the Creationist Society. Okay, so that's what I'm going to share today and the next time. Okay.
Quickly ask a question. I don't know if you plan to address this, but this is something that may need some clarification. Is the light that God created on the first day, it did not depend on the sun, the moon, and the stars.
No, yeah.
Which came on the fourth day. So
first day light is different. First day light is energy, basically, electromagnetic spectrum God created. So fourth day is different. Fourth day means that God created sun, moon, stars. Fourth day is a light, is different thing, two different things. Does that clarify things for you?
Okay, thank you so much.
Okay, good. All right, so now it is a serious problem, right? Because if you are an intellectual person, then you must have this question, not only from those radiometric dating that we covered last time, but also the universe. Look at this. I mean, this is billions of years. How come, right? You can reconcile this with like 6,000 years, 10,000 years, whatever, right? Many Christians suggest that God supernaturally created the beams of light themselves. That means the light beams from every star are created in transit. At the same time, the stars are created. So if you believe that, this will simply solve all this light travel time problem, because your light beams are already here when they're created. This type of belief brings us a logical flow. For example, we look at supernova that exploded in 1987 on the left and the right. Years after explosion, exploded site looks totally different, because since the explosion, it changes shape over time as the gas is spread out to space. And of course, we can observe this change in real time today. And what does that mean? This means that in every split of seconds, the light beams coming to us contain new varying information. In other words, all the light beams contain continuously varying information. Okay, so think about it. If God created the light in transit, then the events we observe beyond about like 10,000 years light year will cover the overwhelming majority that will be fictional. Okay, so you can still choose to believe the light in transit thinking in order to reconcile the light travel time issue with the biblical time frame of fewer than like 10,000 years. But with that thinking, you can't logically explain the issue to the skeptics. It might be difficult for some of you now to fully understand or comprehend what's going on here. But I strongly suggest you carefully examine this later at home, okay? I know you're already home, but later. Okay, so anyway, this is something, this is a homework. This is something that you got to think about later, okay? If you don't understand now. Now, the creation cosmology is the effort in theoretical physics and cosmology to resolve this light travel time issue logically through physical science, okay? And the cosmology and using Einstein's relativity and so on and so forth. So there's few creationist cosmology model, and most of the models are based on galactocentricity, which is the proposition that the galaxy we live in is near the center of the universe. So I will introduce Humphrey's viral cosmology in the next lecture, which also relies on galactocentricity. So first, therefore, we need to understand what the galactocentricity implies and means, okay? If I ask you this question, what would be your answer? Where is the center of the universe? What would be your answer? Maybe it's not easy to answer even, right? So to help you answer the question, I searched Google actually, and this came up. It says there's no such a thing, fool. Okay, there's no such a thing. Why? The Big Bang universe does not allow galactocentricity. Big Bang universe actually does not allow any center. There shouldn't be any center. There shouldn't be any boundary. Okay, because universe has to be homogeneous and isotropic. So that is a Big Bang universe. So what does that mean? And what does this to do with the creation cosmology? It is important to understand this implication first. Okay, so let's find out.